The fundamental counting principle. It's a shortcut from the tree diagram. If you just watched a previous video of mine, counting methods video, I may have mentioned this. This is the easy way of doing some of the ones that I just did in that video. It says if you have m choices for one item, n choices for the second, that means to find the total number of choices, you multiply them together. And that can be extended to for as many items as you have. So, for this first example, how many ways can two coins flip concurrently land? Well, just think about two coins. Each coin can land heads or tails. Right? Right. So that means the first coin has two possibilities. The second coin has two possibilities also. 2 times 2 is 4 possibilities. And how many ways can you get exactly one head? Well, you have to list them. True, true. True, false. False. Well, wrong. Wrong class. That's for a true, false question. So if you see true, false, hey, now you know what to do. So you can do heads, tails, tails, heads. I'm just going to do heads, tails. My bad. I want to do it in order the way my mind thinks. Yes, heads, heads, tails, tails, heads, tails, tails. That's your 4 possible outcomes. How many ways can you get exactly one head? Well, there's one, there's another one, so there's 2 ways. So the answer to the first question is 4. This one is 2. This first part, I just used the fundamental counting principle. Now for this one, you want to buy a car, you got 1, 2, 3, 4 color choices, 3 door styles, and 2 transmission types. So by the fundamental counting principle, you just multiply them out. 4 times 3 is 12, 12 times 2 is 24. Not so bad. Now let's get to a little bit more creative examples. How many 3-letter codes can be created if repeated letters are allowed? Now what I like to do is I like to draw 3 blanks in this case. So we're allowed to repeat letters. That means that A is a possibility. So how many letters in the alphabet are there? There's 26. So how many choices do I have for the first code letter? Well, 26. Since repetition is allowed, how many do I have for the second? 26. How about for the third? 26. And when you multiply that out, 26 times 20 times 26 times 26 is 17,576 different possible combinations. So that's 26 to the third, in case you're wondering. Now here's a different example. How many 3-digit code words can be created if no digit can be used more than once? Now, these are digits. These aren't letters. These are digits. Oh, how many digits are there? Well, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For a grand total of 10 possibilities. And no digit can be used more than once. So once again, it's a 3-digit code. So how many possible digits are there for the first entry? Well, there's 10 total. But no digit can be used more than once. Got that? So let's say they use 0. How many are left? Well, there's 9 left for the second entry. Let's say that I just happen to use a 1. Well, how many are left for the third entry? 8. So if no digit can be used more than once, you have to count for repetitions not being allowed. So that's why it decreases by 1. And then you multiply them out. 8 times 9 is 72. 72 times 10 is 720 possible code words. Now here's a really good example. How many 4-digit numbers can be formed if the first digit cannot be 0 and the last digit must be 2? Repetition is allowed. So this time we'll draw 4 blanks, 4 entries. The first digit cannot be 0. So once again, if you were to list the digits that are possible, single digits, If the first digit cannot be 0, that means you have 9 possibilities. And then the last digit must be 2. So that means this one, how many ways can you have a 2? There's only one way. Now for in here, since repetition is allowed, that means you're going to have a 9 or a 1 here because repetition is allowed. Or I should say, you can have a 0 and you could also have a 1. I shouldn't have said 9, I was looking there. That's not an actual number. It could be, who knows. I just tells you how many possibilities you could have. So that means that this entry could be any of the 10 digits as well as this one. There's no restrictions on it. You're allowed to repeat, and you can use any number you want, any digit. The only ones that have restrictions were the first one, can't be a 0, so that means you had 9 possibilities, and the last one had to be a 2, so you only have 1 possibility there. So you take 9 times 10 is 90, 90 times 10 is 900, times 1 more, or times 1 is 900. And that's how many possible combinations there are. I think that's the last one, and it is.